Hello guys, how are you? Uh, in the previous chapter, chapter 3, uh, you have learned about the basic concepts of artificial intelligence. In this chapter, chapter 4, which is about Internet of Things or IoT, you will learn the overview of IoT, the tools and platforms used for IoT, the advantages and disadvantages of IoT, the architecture of IoT, and finally, you will learn some real sample applications of IoT. So let's directly go to the goal of this chapter. Uh, Once you have completed this chapter, you have to be able to describe exactly what IoT is. What are its pros and cons, the advantages and disadvantages of IoT? How does it work? What is the architecture of IoT? What are the layers of the architecture of IoT? And you will be able to describe also the tools and platforms used for IoT. Finally, uh, you will be able to describe some of the applications of IoT. Let's begin with overview of IoT. Okay, uh, to review the most important features of IoT, uh, it includes the artificial intelligence, connectivity, sensors, active engagement, and small devices. Let's see them one by one. The first one is AI or artificial intelligence. Uh, IoT essentially makes virtually anything smart. In a sense, it enhances every aspect of our life with the power of data collection, with the power or capability of AI algorithms and networks. This can mean something as simple as enhancing your refrigerator, your cabinet to detect when milk and your favorite uh, rate run low, and to then place an order with your preferred grocer. The second one is connectivity. Connectivity means network. Networks can exist on a much smaller and cheaper scale while still being practical. So IoT creates the small networks between its system devices. Another feature is the sensor. IoT lost its distinction without sensors. So sensors are very necessary to make things very smart. Sensors act as defining instruments that transform IoT from a standard passive network of devices into an active system capable of real-world integration. So sensors are very determinant features of IoT. The next one is active engagement. Much of today's interaction with connected technology happens through passive engagement. But IoT introduces a new paradigm, a new principle for active content, product, or service engagements. So this is another feature of IoT, very important feature. The last one is small devices. Devices, as predicted, have become very smaller, cheaper, and more powerful over time. IoT exploits purpose-built small device to deliver its precision, scalability, and versatility. Next, let's discuss what exactly IoT is. IoT can be uh, defined by different groups. By different groups, uh, thus definitions, thus descriptions of IoT are so different from one group to another group. Uh, for example, the term IoT or Internet of Things, according to the 2020 conceptual framework, is expressed through a simple formula such as IoT is equal to services plus data plus networks plus sensors. Um, According to Oxford Dictionary's definition, IoT is the interaction of everyday objects computing devices through the internet that enables the sending and receiving of useful data or information. Generally speaking, IoT is the network of physical objects, in general, things embedded with electronics, software, sensor, and network connectivity, which enables these objects to send and receive useful data, or to collect and exchange data, or to share useful data. Uh, IoT can also be defined as a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifier and the ability to transfer data over a network without requiring human to human or human to computer interaction. Uh, IoT again can also be defined as a network of devices that can sense, accumulate, and transfer data over the internet without any human intervention. So this is the definition of IoT. Now let's see what are the advantages, what are the pros of IoT. Uh, Here are some of the advantages of IoT. Like IoT improved customer engagement, technology optimization, reduced waste. It enhanced data collection. Let's see the advantages of IoT one by one, briefly. Okay, the first one, IoT improved customer engagement. What does it mean? There is currently a system that analyzes info about customers online, but these analytics suffer from blind spots and significant flaws in accuracy, and as noted, engagement remains passive. However, IoT completely transforms this to achieve richer and more effective engagement with audiences or the customers. Technology optimization. The same technologies and data which improve the customer experience, also improve device use and aid in more patent improvements to technology. IoT unlocks a world of critical, functional, and field data. IoT also reduces waste. It makes areas of improvement clear. Current analytics gives us superficial insight, but IoT provides real-world information leading to the more effective management of resources. It also enhances data collection. Modern data collections suffer from its limitations and its design for passive use. Here, IoT breaks it out of the space and places it exactly where human really wants to go to analyze our world. It allows an accurate picture of everything. Uh, Besides its advantages, there are also disadvantages of IoT. Some of the list of disadvantages of IoT are as the number of connected devices increases, the more information is shared between devices. The potential that a hacker could steal confidential information also increase because informations are shared among and between these devices. If there is a bug in the system, it is likely that every connected device will become corrupted. Since there is no international standard of compatibility for IoT, it is difficult for devices from different manufacturers to communicate with each other. Enterprise may eventually have to deal with massive numbers, maybe even millions of IoT devices, and collecting and manufacturing the data from all these devices will be challenging. Let's see the challenges of IoT. The first challenge of IoT is security. It's a major issue for IoT. IoT creates an ecosystem of constantly connected devices communicating over networks. The system offers little control despite any security measures. This leaves users exposed to various kinds of attackers. While these devices are sharing uh, between uh, between themselves, uh, different attacks may be attempted. The second challenge is privacy. Uh, the sophistication of IoT provides substantial personal data in extreme detail without the user's active participation. Uh, Complexity is also another challenge for IoT. Some find IoT systems complicated in terms of uh, design, deployment, and maintenance, given their use of multiple technologies and a large set of new enabling technologies. Flexibility. Many are concerned about the flexibility of an IoT system to integrate easily with another. They worry about finding themselves with several conflicting or locking systems. The last uh, issue or challenge of IoT is compliance. IoT, like any other technology in the uh, realm of business, must comply with regulations. Its complexity makes the issue of compliance seem incredibly challenging when many consider standard software compliance a battle. How does it work? How does it work? An IoT ecosystem consists of web-enabled smart devices that use embedded processor, sensor, and communication hardware to collect, send, and act on data they acquire from their environments. So the smart devices are necessary. IoT devices share the sensor data they collect by connecting to an IoT gateway or another edge device where data is either sent to the cloud to be analyzed or analyzed locally. Sometimes this device communicate with other related devices and act on the information they get from one another. The devices do most of the work without human interventions, although people can interact with the devices. For instance, to set up uh, given them instructions or access the data. The connectivity, networking, and communication protocols used with this web-enabled device largely depend on the specific IoT applications deployment. So, in general, we can summarize that there are web-enabled smart devices which collect data using sensor data. Then, thus, collected data are uh, shared through IoT gateway or can be sent to cloud or to a server for further analyzation. Uh, that's it. That's how IoT works. Uh, the last topic in this part is gonna be about the architecture of IoT. In general, an IoT device can be explained as a network of things that consists of hardware, software, and network connectivity. It also uh, consists the sensors. Hence, the architecture of IoT device comprises the four major components or layers. These are the sensing layer, network layer, data processing layer, and finally the application layer. The first layer is sensing layer. The purpose of sensing layer is to identify any phenomena in the device peripheral and obtain data from the real world. So the purpose is simply to sense data. This layer consists of several sensors. Using multiple sensors for applications is one of the primary features of IoT device. Sensors in IoT device are usually integrated through sensor hubs. They are connected to each other. A sensor hub is a common connection point for multiple sensors that accumulate and forward sensor data to the processing unit of a device. Then there is also actuators. Actuators can also intervene to change the physical conditions that generate the data, the sensing data. Maybe actuator can shut off a power supply, adjust an airflow, or move a robotic gripper in an assembly processor. Sensors in IoT devices are classified into three broad categories: the motion sensor, environmental sensors, and position sensors. Motion sensors measure the change in motion as well as the orientation of the devices. Environmental sensors such as light sensors, pressure sensors, etc., embedded in IoT devices to sense the change in the environment. The third category of sensors in IoT is the position sensor. Position sensors deal with the physical position and location of the devices. The second layer is the network layer. This layer acts as a communication channel to transfer data collected in the sensing layer to other connected devices. In IoT device, the network layer is implemented by using diverse communication technologies. For example, there is a Bluetooth. Thus technologies allow data flow between other devices within the same network. So this connectivity works only devices which are found in the same network or devices which are using the same network. The third layer is the data processing layer. This layer consists of the main data processing units of any IoT smart device. The data processing layer takes data collected in the sensing layer and analyzes the data to make decisions based on the results. In some IoT device like smartwatch, smart home app, etc., the data processing layer also saves the results of previous analysis to improve the user experience. So it uses some memory to store those past experiences. This layer may share the result of data processing with other connected device via the network layer. The last layer is the application layer. The application layer implements and presents the result of the data processing layer to accomplish disparate applications of IoT devices. This layer is a user-centric layer that executes various tasks for the users. There exist diverse IoT applications which include smart transportation, smart home, personal care, healthcare, etc. In the next video, you will learn device and networks.